Imagine a place where stars are born, where the cosmos weaves a tapestry of light and dust, and where the universe reveals its most intimate secrets. This isn't a scene from a science fiction movie. It's the Orion Nebula, a stellar nursery right in our cosmic backyard. In just a few moments, we'll dive into this celestial wonder, exploring its vibrant colors, uncovering its hidden mysteries, and discovering why this nebula is one of the most captivating sights in our night sky. So, buckle up and prepare to journey through space and time as we unveil the breathtaking story of the Orion Nebula. Overview of the Orion Nebula. Nestled in the sword of the constellation Orion, approximately 1,344 light-years away from Earth, lies the Orion Nebula, a vast interstellar cloud of dust, hydrogen, helium, and other ionized gases. This celestial wonder is one of the brightest nebulae visible to the naked eye, a stunning sight that has captivated astronomers and stargazers alike for centuries. Its luminosity is due to the intense ultraviolet radiation emitted by the young, massive stars within it, which excites the surrounding gas, causing it to glow in a dazzling display of cosmic artistry. The Orion Nebula is a stellar nursery, a place where new stars are born. It is part of a much larger star-forming complex that includes the Dark Nebula, the Reflection Nebula, and the Horsehead Nebula. Within the Orion Nebula, the process of star formation is on full display. Dense regions of gas and dust collapse under their own gravity, heating up and eventually igniting nuclear fusion, the process that powers stars. This nebula is home to hundreds of very young stars, some of which are still in the process of accreting material from the surrounding cloud. The most prominent of these stars is the Trapezium, a cluster of 4 massive, bright stars that illuminate the nebula and shape its structure. The Orion Nebula is a treasure trove of astronomical discoveries. It is one of the most scrutinized and photographed objects in the night sky, providing scientists with invaluable insights into the processes of star formation and the early evolution of stellar systems. The nebula's relative proximity to Earth makes it an ideal laboratory for studying the intricate details of star birth. Telescopes like the Hubble Space Telescope have revealed a wealth of information about the Orion Nebula, including the presence of protoplanetary disks, or droplets, which are the building blocks of planetary systems. These disks of dust and gas surround young stars and are the sites where planets are thought to form. The study of the Orion Nebula has also shed light on the role of massive stars in shaping their surroundings, as their intense radiation and stellar winds carve out cavities in the nebula and trigger the formation of new stars. Location and visibility. Nestled in the constellation of Orion, the Orion Nebula is a breathtaking celestial object that has captivated astronomers and stargazers alike. It lies approximately 1,344 light-years away from Earth, a relatively short distance in cosmic terms. This proximity makes it one of the brightest and most easily observable nebulae in the night sky. The nebula is situated below Orion's belt, a prominent asterism consisting of 3 bright stars, Alnitak, Alnilam, and Mintaka. Its location within this well-known constellation makes it a popular target for both amateur and professional astronomers. The Orion Nebula is visible to the naked eye under clear, dark skies, appearing as a faint, fuzzy patch of light. However, its true splendor reveals itself through telescopes or binoculars. Even a modest telescope can unveil the nebula's intricate details, including its glowing clouds of gas and dust and the young stars embedded within. The nebula's apparent magnitude is around 4, making it one of the brightest nebulae in the sky. Its visibility is further enhanced by its large angular size, spanning about 1 degree across the sky, which is roughly twice the diameter of the full moon. The best time to observe the Orion Nebula is during the winter months in the northern hemisphere, when Orion is high in the sky. In the southern hemisphere, it is visible during the summer. The nebula is particularly striking when viewed from a location far removed from city lights, where light pollution is minimal. On a clear night, the nebula's luminous glow can be seen even with the unaided eye, but its true beauty is best appreciated through optical aids. The nebula's vibrant colors, ranging from deep reds to ethereal blues, are a testament to the complex processes of star formation taking place within it. The Orion Nebula is a stellar nursery, a place where new stars are born from the collapse of dense clouds of gas and dust. This dynamic environment is illuminated by the intense ultraviolet radiation from the young, hot stars that have recently formed within it. The nebula's visibility is a result of this interaction, as the radiation ionizes the surrounding gas, causing it to emit light in a process known as fluorescence. This interplay of light and matter creates a mesmerizing display of colors and shapes, offering a glimpse into the very origins of our universe. Historical observations. The Orion Nebula, a celestial jewel hanging from the belt of the constellation Orion, has been a beacon of wonder for centuries. Its historical observations are a tapestry woven with threads of curiosity and discovery. Ancient astronomers, gazing up at the night sky, were among the first to notice this fuzzy patch in the sword of Orion. The nebula's visibility to the naked eye made it a subject of intrigue and speculation long before the invention of telescopes. Early stargazers, including the ancient Mayans and the inhabitants of the South Pacific, recorded its presence, attributing it to various mythological significance. The true nature of the Orion Nebula began to unfold with the advent of telescopic observations. In 1610, the French astronomer Nicolas Claude Fabry de Peiresc is credited with the first telescopic observation of the nebula. However, it was Galileo Galilei who, around the same time, provided a more detailed description, noting its nebulous appearance. The nebula's ethereal glow and complex structure captivated astronomers, sparking a desire to unravel its mysteries. Over the centuries, advancements in telescope technology allowed for increasingly detailed observations, revealing the nebula's intricate patterns and vibrant colors. One of the most significant milestones in the historical observations of the Orion Nebula came with the work of William Herschel in the late 18th century. Herschel, a prolific astronomer, cataloged the nebula and provided extensive notes on its appearance and structure. His observations laid the groundwork for future studies, inspiring generations of astronomers to delve deeper into the nebula's secrets. The Orion Nebula's prominence in the night sky made it a natural target for early astrophotographers, who captured its beauty in stunning detail, further fueling public fascination. As our understanding of the cosmos has evolved, so too has our appreciation for the Orion Nebula. Modern telescopes, equipped with advanced imaging technology, have revealed the nebula's true nature as a stellar nursery. Within its glowing clouds, new stars are born, their formation illuminated by the intense radiation of nearby massive stars. The nebula's historical observations have thus become a testament to human curiosity and the relentless pursuit of knowledge. Each discovery, each new insight, adds another layer to the rich tapestry of our understanding of the universe. Early scientific studies. In the vast canvas of the night sky, the Orion Nebula has long been a beacon of fascination for astronomers. This stellar nursery, located in the constellation of Orion, is a vast cloud of gas and dust where new stars are born. Early scientific studies of the Orion Nebula were marked by a sense of wonder and discovery, as astronomers began to unravel the mysteries of this celestial object. The nebula's bright, glowing core, visible even to the naked eye, has been a subject of intrigue since ancient times. However, it was not until the advent of the telescope that scientists could begin to study it in detail. One of the earliest recorded observations of the Orion Nebula was made by the French astronomer Nicolas Claude Fabry de Peiresc in 1610. Using a telescope, he was able to discern the nebula's fuzzy, extended nature, distinguishing it from the sharp points of stars. This observation marked a significant milestone in the early scientific studies of the nebula. Over the following centuries, astronomers continued to observe and document the Orion Nebula, noting its distinctive features and peculiarities. The nebula's complex structure, with its intricate filaments and knots of gas, presented a challenge to early astronomers, who struggled to understand its true nature. The Orion Nebula's prominence in the night sky made it an ideal target for early spectroscopic studies. In the 19th century, astronomers began to analyze the light from the nebula, breaking it down into its component colors and wavelengths. This technique, known as spectroscopy, revealed the chemical composition of the nebula and provided clues about the physical processes at work within it. One of the most significant discoveries made through spectroscopy was the identification of novel spectral lines in the Orion Nebula. These lines, which did not correspond to any known chemical elements on Earth, were initially a source of great puzzlement. It was not until the early 20th century that these lines were attributed to highly ionized oxygen and nitrogen, a testament to the extreme conditions within the nebula. As astronomical technology advanced, so too did our understanding of the Orion Nebula. The development of photography in the late 19th century allowed astronomers to capture detailed images of the nebula, revealing its intricate structure in unprecedented detail. These images showed a complex network of glowing gas and dark lanes of dust, a testament to the dynamic processes at work within the nebula. The Orion Nebula's status as a stellar nursery was confirmed through these studies, as astronomers observed the formation of new stars within its gaseous embrace. This discovery was a profound moment in the early scientific studies of the nebula, shedding light on the very processes that give birth to stars and planetary systems. Modern astronomical techniques. The Orion Nebula, a vast cloud of gas and dust, is one of the most studied objects in the night sky. It's a stellar nursery, a place where new stars are born, and modern astronomical techniques have allowed us to peer into its depths like never before. Telescopes equipped with adaptive optics can correct for the distortions caused by Earth's atmosphere, providing incredibly sharp images. These images reveal the intricate details of the nebula's structure, including the dense knots of gas and dust where stars are forming. Spectroscopy, another powerful tool, allows astronomers to analyze the light from the nebula and determine its chemical composition, temperature, and velocity. This information helps us understand the processes driving star formation. For instance, the nebula's bright glow comes from the ionization of hydrogen gas by the intense ultraviolet radiation from nearby massive stars. This radiation also sculpts the nebula's appearance, creating the dramatic shapes and filaments we see in images. Interferometry, a technique that combines the light from multiple telescopes, provides even greater resolution. The Atacama Large Millimeter/Submillimeter Array, ALMA, for example, uses this method to study the cold, dark regions of the nebula where stars are just beginning to form. ALMA's observations have revealed the presence of complex organic molecules, hinting at the potential for planet formation and, perhaps, the origins of life. Moreover, space-based telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope offer unparalleled views of the Orion Nebula. Free from the distortions of Earth's atmosphere, these telescopes can capture images and data that ground-based observatories simply can't. They've allowed us to study the nebula's protoplanetary disks, the swirling disks of gas and dust around young stars that may one day form planetary systems. Each new observation adds another piece to the puzzle, bringing us closer to understanding the mysteries of star and planet formation, structure, and composition. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, lies a celestial spectacle that has captivated astronomers and stargazers alike, the Orion Nebula. This vast interstellar cloud is a stellar nursery, a place where new stars are born, and it presents a mesmerizing tapestry of cosmic creation. At its heart, the nebula is a complex structure composed primarily of hydrogen and helium gas, with traces of heavier elements like oxygen, carbon, and nitrogen. These elements are the building blocks of stars, planets, and even life as we know it. The nebula's composition is not uniform. It varies across its expanse, creating a dynamic and ever-changing environment. The Orion Nebula's structure is as awe-inspiring as its composition. It spans about 24 light-years across, a distance that is difficult to comprehend, yet it is just a small part of the vast Orion molecular cloud complex. Within this nebula, dense regions of gas and dust, known as molecular clouds, collapse under their own gravity, giving birth to new stars. These young stars, often referred to as protostars, are surrounded by disks of material that may eventually form planetary systems. The nebula's structure is further shaped by the intense radiation and stellar winds from these young, hot stars, which carve out cavities and create the intricate patterns we observe. One of the most striking features of the Orion Nebula is the Trapezium Cluster, a group of young, massive stars at the nebula's core. These stars are responsible for illuminating the nebula, making it one of the brightest nebulae in the night sky. The intense ultraviolet radiation from the trapezium stars ionizes the surrounding gas, causing it to glow with a characteristic reddish hue. This phenomenon, known as fluorescence, is a testament to the dynamic interplay between stars and their environment. The nebula's structure is also characterized by dark lanes of dust, which absorb and scatter light, creating a stark contrast against the glowing gas. The Orion Nebula is a treasure trove of astronomical wonders. It contains a variety of objects, including Herbig-Haro objects, which are small patches of nebulosity associated with newly born stars, and protoplanetary disks, which are the potential birthplaces of new planetary systems. The nebula's composition and structure provide a unique opportunity for scientists to study the processes of star formation and the early evolution of stellar systems. By observing the Orion Nebula, astronomers gain insights into the conditions that prevailed during the formation of our own solar system, offering a glimpse into our cosmic origins. The nebula's beauty and scientific significance make it a symbol of human curiosity and our quest to understand the universe. The Great Nebula in Orion. Nestled in the sword of the constellation Orion, a mere 344 light-years away, lies the Orion Nebula, a celestial spectacle that has captivated astronomers and stargazers alike. This vast interstellar cloud of dust, hydrogen, helium, and other ionized gases is a hotbed of star formation, a stellar nursery where the universe is constantly renewing itself. The nebula's most prominent feature is the Great Nebula in Orion, a region of intense brightness and activity that reveals the intricate dance of creation. The Great Nebula in Orion is a treasure trove of astronomical wonders. At its heart lies the Trapezium Cluster, a group of young, massive stars that emit intense ultraviolet radiation, illuminating the surrounding gas and causing it to glow with an ethereal light. This radiation also sculpts the nebula, creating the dramatic shapes and structures that have made the Orion Nebula an iconic object in the night sky. The nebula's vibrant hues, ranging from deep reds to brilliant blues, are a result of different gases being excited by the starlight. Oxygen emits a blue glow, hydrogen shines red, and nitrogen produces a greenish light, painting a cosmic canvas that is both awe-inspiring and humbling. Within the Orion Nebula, the process of star formation is on full display. Dense pockets of gas and dust collapse under their own gravity, heating up and eventually igniting nuclear fusion, the process that powers stars. These young stars are often surrounded by protoplanetary disks, swirling masses of material that may one day form planetary systems. The Orion Nebula is also home to numerous Herbig-Haro objects, small patches of nebulosity associated with newly born stars. These objects are created when jets of gas ejected by young stars collide with the surrounding nebula, creating shockwaves that light up the gas. The Orion Nebula is not just a sight to behold, it is also a laboratory for astronomers. By studying this stellar nursery, scientists can gain insights into the processes that govern star formation and the evolution of planetary systems. The nebula's relative proximity makes it an ideal target for detailed observations, and it has been studied extensively using ground-based telescopes and space-based observatories like the Hubble Space Telescope. Each new observation reveals more about the complex interplay of forces that shape the nebula and the stars within it. The Orion Nebula, with its breathtaking beauty and scientific significance, stands as a testament to the wonders of the universe and the enduring human quest for knowledge. The Trapezium Cluster. Nestled within the heart of the Orion Nebula, a mere 344 light-years away from Earth, lies the Trapezium Cluster, a dazzling group of young, massive stars that serve as the powerhouse illuminating this stellar nursery. This cluster is home to at least 6 prominent stars, with 4 of them forming a distinctive trapezoid shape, hence the name. These stars are incredibly hot and massive, with surface temperatures exceeding 30 degrees Celsius and masses ranging from 15 to 30 times that of our Sun. Their intense ultraviolet radiation ionizes the surrounding hydrogen gas, causing the Orion Nebula to glow with a mesmerizing, ethereal light. The Trapezium Cluster is a hotbed of stellar activity, where stars are born and evolve at a rapid pace. The intense radiation and stellar winds from these massive stars shape the nebula, carving out cavities and creating intricate structures within the gas and dust. This dynamic environment is a goldmine for astronomers, offering a unique opportunity to study the processes of star formation and the interactions between young stars and their surroundings. The cluster's relatively close proximity to Earth makes it an ideal natural laboratory for observing these phenomena in detail. Among the stars in the Trapezium Cluster, the most massive and luminous is Theta 1 Orionis C, a binary star system consisting of two O-type stars. These stars are so hot and bright that they dominate the cluster's appearance and influence its evolution. Their powerful stellar winds and intense radiation create shock waves that compress the surrounding gas, triggering the formation of new stars. This process, known as triggered star formation, is a crucial aspect of the Orion Nebula's stellar nursery, as it gives rise to the next generation of stars. The Trapezium Cluster is also home to a diverse population of smaller, less massive stars, as well as brown dwarfs and protostars. These objects are often overshadowed by their more massive counterparts, but play a vital role in the cluster's dynamics and evolution. By studying the entire stellar population of the Trapezium Cluster, astronomers can gain insights into the complex processes that govern star formation and the early evolution of stellar systems. The cluster's rich tapestry of stars, gas, and dust offers a captivating glimpse into the wonders of our universe, inspiring awe and discovery among those who gaze upon it. Stellar formation processes. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, the Orion Nebula is a vast interstellar cloud where stars are born. This stellar nursery is a treasure trove for astronomers, offering a glimpse into the processes that give rise to new stars. At its heart lies a young, massive star cluster known as the Trapezium, which illuminates the nebula and drives its complex chemistry. The Orion Nebula is a prime example of a stellar formation process, where gravity pulls together clouds of gas and dust, leading to the birth of new stars. The journey of stellar formation begins with molecular clouds, vast regions of cold, dense gas, and dust. In the Orion Nebula, these clouds are predominantly composed of hydrogen, the most abundant element in the universe. Gravity causes these clouds to collapse, and as they do, they fragment into smaller, denser cores. These cores continue to collapse, heating up due to the conservation of angular momentum. When the temperature and pressure at the core become sufficient, nuclear fusion ignites, and a protostar is born. This process is ongoing in the Orion Nebula, with countless protostars embedded within the dense molecular clouds. As the protostars grow, they begin to emit powerful stellar winds and radiation, which shape the surrounding nebula. These winds can blow away the remaining gas and dust, halting the formation of new stars in the vicinity. However, they can also compress nearby gas clouds, triggering the birth of a new generation of stars. This cyclical process is evident in the Orion Nebula, where regions of active star formation coexist with areas where the stellar winds have carved out vast cavities. The interplay between these forces creates the intricate structures and vivid colors that make the Orion Nebula a sight to behold. The Orion Nebula is also a hotbed for the formation of planetary systems. As protostars form, they are surrounded by disks of gas and dust known as protoplanetary disks. These disks are the building blocks for planetary systems, where planets, moons, and other celestial bodies coalesce. Observations of the Orion Nebula have revealed numerous protoplanetary disks, providing valuable insights into the early stages of planetary system formation. The study of these disks helps astronomers understand the conditions that give rise to habitable planets and the potential for life beyond our solar system. In this way, the Orion Nebula not only offers a window into the birth of stars, but also into the formation of planetary systems and the possibility of life elsewhere in the universe. Protostars and young stellar objects. Nestled within the constellation of Orion, approximately 1,344 light-years away from Earth, lies the Orion Nebula, a vast interstellar cloud where stars are born. This stellar nursery is a treasure trove of celestial wonders, with protostars and young stellar objects, YSOs, taking center stage in the grand cosmic ballet of star formation. At the heart of the nebula, a cluster of young, massive stars, known as the Trapezium, illuminates the surrounding gas and dust, revealing the intricate processes that give rise to new stars. Protostars, the embryonic stages of star formation, are born from the collapse of dense regions within molecular clouds. In the Orion Nebula, these protostars are enshrouded in thick cocoons of gas and dust, making them difficult to observe at visible wavelengths. However, infrared and radio telescopes, such as the Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array, ALMA, have pierced the veil, revealing the intricate details of these stellar infants. Protostars are characterized by their intense accretion of material as they grow in mass and density, eventually igniting nuclear fusion in their cores. This process is not gentle. It is a tumultuous and dynamic phase, marked by powerful outflows and jets that carve out cavities in the surrounding nebula. Young stellar objects, the successors to protostars, are the adolescent stars that have begun to clear their surroundings, revealing their nascent light. These YSOs are classified into several stages, based on their spectral energy distributions and the presence of circumstellar disks. T-Tauri stars, for instance, are YSOs that have completed their main accretion phase and are now powered by gravitational contraction. They are often found in the Orion Nebula, their youthful energy illuminating the surrounding gas and dust. Herbig-Haro objects, on the other hand, are small patches of nebulosity associated with newly born stars, formed when stellar winds or jets collide with the interstellar medium. These objects are ubiquitous in the Orion Nebula. Their vibrant colors and dynamic shapes a testament to the violent and chaotic nature of star formation. The Orion Nebula is a veritable laboratory for studying the processes that give rise to stars and planetary systems. Protostars and YSOs, with their diverse array of phenomena, offer astronomers a unique opportunity to witness the birth and early evolution of stars. From the intense accretion of protostars to the powerful outflows of YSOs, the nebula is a dynamic and ever-changing landscape, shaped by the forces of gravity, magnetism, and radiation. As our understanding of these processes deepens, so too does our appreciation for the wonders of the cosmos and our place within it. The Orion Nebula, with its stellar nursery, stands as a beacon of discovery, inviting us to explore the mysteries of the universe and the origins of our own solar system. Accretion disks and outflows. Nestled within the constellation of Orion, approximately 1,344 light-years away from Earth, lies the Orion Nebula, a vast interstellar cloud of dust, hydrogen, helium, and ionized gases. This celestial wonder is not just a stunning sight through a telescope. It's a bustling stellar nursery where new stars are born. At the heart of this process are accretion disks and outflows, two phenomena that play a crucial role in the formation of stars and planetary systems. Accretion disks are swirling, flattened structures of gas and dust that form around young stellar objects, or protostars. As the protostar grows by accreting material from the surrounding molecular cloud, the angular momentum of the infalling material causes it to flatten into a disk. This is similar to how a spinning ice skater pulls in their arms to increase their spin. The accretion disk is where the action happens. It's here that material is funneled onto the protostar, and where planets may eventually form from the leftover material. The disks can be incredibly hot, with temperatures reaching thousands of degrees, and they emit a range of radiation, from radio waves to 10th rays. Meanwhile, outflows are streams of high-velocity gas that are ejected from the poles of the protostar, perpendicular to the accretion disk. These outflows, also known as jets, are thought to be driven by the magnetic fields of the protostar and the accretion disk. They can extend for light years and can have a profound impact on the surrounding interstellar medium. Outflows are not just a byproduct of star formation. They play an active role in shaping the environment around the young star. They can help to clear away the remaining gas and dust, potentially halting the growth of the star and influencing the formation of any planetary system. In the Orion Nebula, these outflows can be seen as bright, streaking features, adding to the nebula's stunning visual display. The study of accretion disks and outflows in the Orion Nebula has provided astronomers with valuable insights into the process of star formation. By observing these phenomena, scientists can better understand the physical processes that govern the birth of stars and the formation of planetary systems. The Orion Nebula, with its wealth of young stellar objects, is a prime target for such studies. It offers a unique opportunity to observe these processes in action, providing a window into the early stages of stellar evolution. The data collected from these observations can then be used to refine models of star formation, helping to paint a more complete picture of how stars and planets come to be. Herbig-Haro objects. Nestled within the Orion Nebula, a vast stellar nursery teeming with newborn stars and swirling gases, lie enigmatic objects known as Herbig-Haro (HH) objects. These captivating phenomena are energetic outflows of gas and plasma that are ejected by newly formed stars, creating dazzling displays of cosmic artistry. HH objects are relatively small, often spanning only a few light years, but their impact on the surrounding nebula is profound. They are named after astronomers George Herbig and Guillermo Haro, who independently discovered and studied these objects in the mid-20th century. The birth of a star is a tumultuous event, and HH objects are a testament to this cosmic upheaval. As a young star begins to coalesce from a collapsing cloud of gas and dust, it forms a protostar surrounded by a rotating disk of material. The intense magnetic fields and rotational energy of the protostar can launch powerful jets of plasma along its rotational axis. These jets collide with the surrounding interstellar medium at supersonic speeds, creating shockwaves that heat the gas and cause it to emit light. The result is a stunning array of glowing, often colorful, nebular features that we observe as HH objects. Each HH object tells a unique story of stellar birth and evolution. Some appear as small, compact knots of light, while others stretch out into long, intricate filaments that snake through the nebula. The colors of HH objects can vary depending on the elements present in the gas and the temperature of the shockwaves. For instance, hydrogen gas typically emits a reddish glow, while oxygen can produce a bluish hue. These vibrant displays not only provide a visual spectacle, but also offer valuable insights into the physical processes governing star formation. By studying HH objects, astronomers can probe the conditions and mechanisms that give rise to new stars, shedding light on the very origins of our universe. The Orion Nebula, with its rich tapestry of HH objects, serves as an ideal laboratory for exploring these phenomena. Telescopes like the Hubble Space Telescope have captured breathtaking images of HH objects within the nebula, revealing intricate details and complex structures. These observations have shown that HH objects are not static. They evolve over time, with their shapes and intensities changing as the underlying jets interact with their surroundings. Some HH objects even exhibit periodic behavior, with their brightness fluctuating in a regular pattern. This dynamic nature adds another layer of fascination to these already captivating objects, highlighting the ever-changing and dynamic environment of a stellar nursery. Molecular clouds and star formation. Nestled within the constellation of Orion, approximately 1,344 light-years away from Earth, lies the Orion Nebula, a dazzling stellar nursery that has captivated astronomers and stargazers alike. This nebula is a vast interstellar cloud where new stars are born, a process intricately linked to the presence of molecular clouds. These clouds, primarily composed of hydrogen molecules, are the birthplaces of stars, and their dynamics and properties play a crucial role in star formation. The Orion Nebula, with its rich tapestry of gas and dust, offers a unique window into the early stages of stellar evolution. Molecular clouds are vast, cold, and dense regions of the interstellar medium. They are primarily composed of molecular hydrogen, H2, along with trace amounts of other molecules such as carbon monoxide, CO, ammonia, NH3, and water, H2O. These clouds are often referred to as stellar nurseries because they provide the raw materials and the right conditions for star formation. Within these clouds, gravity pulls gas and dust together, forming dense cores that eventually collapse under their own weight. This collapse leads to the formation of protostars, the precursors to main-sequence stars like our Sun. The Orion Nebula is a prime example of a region where molecular clouds are actively forming new stars. It is part of a much larger complex of molecular clouds known as the Orion Molecular Cloud Complex. This complex includes several other notable nebulae, such as the Horsehead Nebula and the Flame Nebula. The Orion Nebula itself is illuminated by the intense ultraviolet radiation from a group of massive, young stars known as the Trapezium Cluster. These stars, which are still in the process of forming, heat and ionize the surrounding gas, causing it to glow with a characteristic pink hue. The process of star formation within molecular clouds is complex and multifaceted. It begins with the gravitational collapse of a dense core within the cloud. As the core collapses, it fragments into smaller, denser clumps, each of which can potentially form a star. These clumps continue to collapse and heat up, eventually reaching temperatures high enough to initiate nuclear fusion. Once fusion begins, a protostar is born, and it begins to shine brightly, heralding the birth of a new star. The Orion Nebula provides a stunning example of this process in action, with its myriad of young stars and protostars embedded within the glowing gas and dust. The role of gravity. In the vast, velvet expanse of our night sky, the Orion Nebula hangs like a luminous jewel, a stellar nursery where gravity plays the role of a master sculptor. This vast cloud of gas and dust, located approximately 1,344 light-years away from Earth, is a hotbed of star formation. Gravity, the invisible force that governs the cosmos, is the architect of this celestial spectacle. It pulls together the diffuse gas and dust, causing them to clump and condense. As these clumps grow denser, they begin to collapse under their own gravitational pull, forming the seeds of new stars. The process is a ballet of cosmic proportions, a dance choreographed by gravity. As the collapsing gas and dust spin faster and faster, they flatten into a disk, much like a spinning pizza dough being stretched out by a chef. At the center of this disk, a protostar begins to form. This is a crucial stage in the life of a star, a moment of creation that gravity orchestrates with precision. The protostar continues to grow, feeding on the surrounding gas and dust until it becomes hot and dense enough to ignite nuclear fusion. And thus, a new star is born, its light piercing the darkness of the Orion Nebula. But gravity's role doesn't end with the birth of a star. It continues to shape the nebula, pulling stars together to form clusters, and even creating complex structures within the nebula itself. The Trapezium Cluster, a group of young, massive stars at the heart of the Orion Nebula, is a testament to gravity's power. These stars are so close together that they appear to be almost touching, a stark contrast to the isolation of older stars. Gravity has also sculpted the nebula's iconic features, like the Dark Nebula, a region so dense that it blocks out the light from behind it. The Orion Nebula is a testament to the power of gravity, a force that shapes the cosmos on a scale we can barely comprehend. It's a reminder that we are part of a vast, interconnected universe, where every atom, every star, every galaxy is connected by the invisible threads of gravity. And as we gaze up at the night sky, we are not just looking at a beautiful spectacle. We are witnessing the birth of stars, the dance of galaxies, and the eternal ballet of gravity. The role of magnetic fields. In the vast, star-studded tapestry of the Orion Nebula, a celestial dance of creation unfolds, choreographed in part by the invisible, yet powerful, embrace of magnetic fields. These fields, threading through the nebula's gas and dust, play a pivotal role in the birth of stars, shaping the very fabric of this stellar nursery. They are the unseen architects, guiding the collapse of dense molecular clouds, the cradles of nascent stars. The fields exert a gentle, yet firm, influence, channeling the inflowing material and regulating the rate at which it feeds the protostars. Without them, the process of star formation would be a chaotic, inefficient affair. The magnetic fields in the Orion Nebula are not uniform. They vary in strength and direction, creating a complex web that permeates the nebula. This intricate network is thought to be generated by the motion of ionized gas, a process known as dynamo action. As the gas swirls and eddies, it generates electric currents, which in turn create magnetic fields. These fields, once established, can persist for long periods, exerting their influence on the surrounding gas and dust. They can also interact with each other, creating a dynamic, ever-changing landscape that shapes the nebula's evolution. One of the most striking manifestations of magnetic fields in the Orion Nebula is the presence of bipolar outflows. These are jets of gas and dust that stream away from protostars in opposite directions, perpendicular to the plane of the accretion disk. The outflows are thought to be driven by the interaction between the protostar's magnetic field and the accreting material. As the material spirals inwards, it is funneled along the magnetic field lines, which channel it towards the protostar's poles. There, it is ejected as a high-velocity jet, carving out cavities in the surrounding gas and dust. These outflows are not just spectacular displays of cosmic fireworks. They also play a crucial role in regulating the star formation process, preventing the protostar from accreting too much material and becoming too massive. The study of magnetic fields in the Orion Nebula is a vibrant, active field of research. Astronomers use a variety of techniques to probe these fields, including the Zeeman effect, which causes the splitting of spectral lines in the presence of a magnetic field, and the polarization of starlight, which can reveal the orientation of the field. Recent observations have revealed a surprising degree of complexity in the nebula's magnetic field structure, with fields that are twisted, tangled, and even knotted. This complexity is thought to be a result of the nebula's dynamic, turbulent environment, where gas and dust are constantly in motion, driven by the energy released by the forming stars. As our understanding of these fields deepens, so too does our appreciation of the intricate, interconnected processes that shape the Orion Nebula and other stellar nurseries throughout the universe. The role of turbulence. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, lies the Orion Nebula, a vast interstellar cloud where stars are born. This stellar nursery is a hotbed of activity, with turbulence playing a pivotal role in its evolution and the formation of new stars. Turbulence, in this context, refers to the chaotic, irregular motions of gas and dust within the nebula, driven by various energy sources, including gravity, radiation, and stellar winds. These turbulent motions create complex structures, from dense clumps to vast cavities, setting the stage for star formation. The Orion Nebula is a dynamic environment, with turbulence acting as a cosmic mixer, stirring up the gas and dust and causing it to clump together. These dense clumps, known as molecular clouds, become the birthplaces of new stars. Turbulence also generates shock waves, which compress the gas and dust, further aiding in the collapse of these molecular clouds. This process is not uniform, however. Turbulence creates a patchwork of densities within the nebula, with some regions collapsing under gravity to form stars, while others remain diffuse and do not. One of the most striking features of the Orion Nebula is the Trapezium Cluster, a group of young, massive stars at the nebula's heart. These stars, formed from the collapse of dense molecular clouds, emit intense radiation and stellar winds, which in turn drive further turbulence within the nebula. This creates a feedback loop where star formation triggers more turbulence, which then triggers more star formation. This process is thought to be a key driver of the nebula's ongoing evolution. Turbulence also plays a crucial role in regulating the star formation process. By stirring up the gas and dust, turbulence can prevent the collapse of molecular clouds, thereby slowing down star formation. This regulation is essential, as it prevents the nebula from forming stars too quickly, which would otherwise deplete its gas and dust reserves. Instead, turbulence ensures that star formation is a gradual, sustained process, allowing the Orion Nebula to remain a prolific stellar nursery. The interplay of these forces creates a breathtaking cosmic ballet, a testament to the wonders of the universe and the intricate processes that give birth to stars. Stellar feedback and nebula dynamics. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, The Orion Nebula is a vast interstellar cloud where new stars are born. This stellar nursery is a dynamic and complex environment, shaped by the intricate interplay of stellar feedback and nebula dynamics. At its heart lies a cluster of young, massive stars, collectively known as the Trapezium, whose intense ultraviolet radiation and stellar winds sculpt the surrounding gas and dust. These processes, collectively termed stellar feedback, play a pivotal role in the nebula's evolution and the formation of new stars. The Orion Nebula is predominantly composed of hydrogen, along with traces of other elements and dust particles. Stellar feedback from the Trapezium stars ionizes the hydrogen gas, causing it to emit the characteristic reddish glow that makes the nebula visible to us. This ionization process also creates shock waves that compress nearby gas and dust, triggering the gravitational collapse that leads to the birth of new stars. The nebula's dynamics are further influenced by the outflow of material from these young stars, which can both hinder and promote star formation in different regions. One of the most striking features of the Orion Nebula is its intricate structure, which includes dense molecular clouds, ionized gas, and regions of active star formation. The stellar winds and radiation from the massive stars in the Trapezium create cavities and filaments within the nebula, shaping its overall appearance. These winds also drive turbulence in the gas, which can either facilitate or disrupt the formation of new stars. For instance, the turbulence can create dense clumps of gas that collapse under their own gravity, while also dispersing other regions, preventing star formation. The Orion Nebula is a treasure trove of astronomical wonders, with numerous protoplanetary disks, Herbig-Haro objects, and stellar jets visible within its boundaries. These features provide valuable insights into the processes of star and planet formation. For example, the protoplanetary disks, often referred to as droplets, are regions where planets are likely forming around young stars. The Herbig-Haro objects and stellar jets are outflows of material from these young stars, which can interact with the surrounding nebula, creating spectacular displays of light and motion. Studying these phenomena helps astronomers understand the complex dynamics at play in stellar nurseries like the Orion Nebula. The Orion Nebula Cluster. Nestled within the constellation of Orion, approximately 1,344 light-years away from Earth, lies the Orion Nebula, a vast interstellar cloud of dust, hydrogen, helium, and ionized gases. At its heart beats the Orion Nebula Cluster, a bustling stellar nursery teeming with young, hot stars. This cluster is a treasure trove of astronomical wonders, offering scientists a front-row seat to the dramatic process of star formation. The cluster's stars, born from the nebula's collapsing clouds of gas and dust, are estimated to be just a few million years old, making them relative infants in the cosmic timeline. Among these stars, the four brightest, known as the Trapezium, form a distinctive asterism that has captivated stargazers for centuries. The Orion Nebula Cluster is a hive of activity, with over 20 young stars packed into a region spanning about 15 light-years. These stars are not merely passive observers in their celestial nursery. They interact with the surrounding nebula, shaping its structure and influencing its evolution. The intense ultraviolet radiation from the massive, hot stars in the Trapezium ionizes the nebula's hydrogen gas, causing it to emit the characteristic red glow that makes the Orion Nebula one of the most spectacular objects in the night sky. This interplay between the stars and the nebula creates a dynamic environment, where stellar winds and radiation sculpt the surrounding gas and dust into intricate shapes and filaments. Within this stellar crucible, astronomers have discovered a wealth of phenomena that provide insights into the early stages of star formation. Protoplanetary disks, the precursors to planetary systems like our own, have been observed around many of the young stars in the cluster. These disks, composed of gas and dust, are the raw materials from which planets coalesce. Additionally, the Orion Nebula Cluster hosts a variety of other objects, including Herbig-Haro objects, which are small patches of nebulosity associated with newly born stars. These objects are created when jets of gas ejected by young stars collide with the surrounding interstellar medium, creating shock waves that heat and ionize the gas, making it visible to astronomers. The Orion Nebula cluster is not just a site of star formation. It is also a laboratory for studying the physical processes that govern the evolution of stellar systems. By observing the cluster, astronomers can test theories of star formation and planetary system development. For instance, the high resolution of the Hubble Space Telescope has allowed scientists to study the Orion Nebula cluster in unprecedented detail, revealing the complex interactions between the young stars and their environment. This research has provided valuable data on the masses, ages, and compositions of the stars, as well as the properties of the protoplanetary disks and other objects within the cluster. The Orion Nebula cluster, with its rich tapestry of stellar activity, continues to be a source of wonder and discovery, offering a glimpse into the very origins of our universe, stellar populations, and evolution. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, the Orion Nebula is a vast interstellar cloud where stars are born. This stellar nursery is a treasure trove of astronomical wonders, offering insights into the life cycle of stars. At its heart lies a young, massive star cluster known as the Trapezium, which is responsible for illuminating the nebula and driving its dynamic processes. The Orion Nebula is a prototypical example of a stellar nursery, providing astronomers with a unique opportunity to study star formation in detail. The nebula is teeming with a diverse population of stars at various stages of evolution. Young, hot, and massive stars, known as OB stars, dominate the central regions. These stars are incredibly luminous, emitting intense ultraviolet radiation that ionizes the surrounding hydrogen gas, causing it to glow with a characteristic reddish hue. The Trapezium Cluster, in particular, is home to several of these OB stars, which are only a few million years old. Their powerful stellar winds and radiation sculpt the nebula, creating intricate patterns and driving the formation of new stars. Surrounding the central cluster, a myriad of smaller, cooler stars can be found. These stars, often referred to as low-mass stars, are less massive than the Sun and have longer lifespans. They form from the collapse of dense cores within the nebula's molecular clouds. The Orion Nebula is also home to numerous protostars, which are stars in the earliest stages of formation. These objects are deeply embedded within the nebula's dusty clouds and are often only detectable at infrared and radio wavelengths. Studying these protostars provides valuable insights into the initial conditions of star formation and the processes that govern the birth of new stars. The Orion Nebula is a dynamic and evolving environment. As massive stars age, they eventually exhaust their nuclear fuel and explode as supernovae. These explosive events inject enormous amounts of energy and heavy elements into the interstellar medium, enriching the nebula and triggering the formation of new stars. The nebula's complex structure and chemistry are a testament to its rich history of star formation and evolution. By studying the Orion Nebula, astronomers gain a deeper understanding of the processes that shape the universe and the life cycle of stars. The nebula's vibrant colors and intricate patterns are a constant reminder of the beauty and wonder of the cosmos. The Orion Nebula's influence on nearby stars. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, the Orion Nebula is a vast interstellar cloud where new stars are born. This stellar nursery is a hotbed of activity, with intense ultraviolet radiation and stellar winds sculpting the surrounding environment. The nebula's influence extends far beyond its visible boundaries, shaping the evolution of nearby stars in profound ways. At its core, the Trapezium Cluster, a group of young, massive stars, emits copious amounts of radiation that ionizes the surrounding gas, creating the nebula's characteristic glow. This energetic output doesn't just illuminate the cosmos, it also plays a pivotal role in the development of neighboring stellar systems. The Orion Nebula's influence on nearby stars is a testament to the interconnectedness of the cosmos. The intense radiation and stellar winds from the Trapezium Cluster can both nurture and disrupt the formation of new stars. On one hand, these forces can compress nearby gas clouds, triggering the collapse of material and initiating star formation. This process, known as radiative-driven implosion, can lead to the birth of new stars in the vicinity of the nebula. On the other hand, the same energetic outputs can also disperse gas and dust, potentially halting the formation of stars in certain regions. This dual role highlights the complex and dynamic nature of stellar nurseries like the Orion Nebula. One of the most striking examples of the Orion Nebula's influence is its impact on the nearby protoplanetary disks, often referred to as droplets. These disks of gas and dust surrounding young stars are the building blocks of planetary systems. The intense ultraviolet radiation from the Trapezium Cluster can photoevaporate the outer layers of these disks, shaping their evolution and potentially influencing the formation of planets. Observations have revealed that droplets closer to the nebula's core are more likely to exhibit cometary tails, pointing away from the intense radiation source. This phenomenon provides a vivid illustration of how the Orion Nebula's influence extends even to the earliest stages of planetary system formation. The Orion Nebula's role in shaping nearby stars is not limited to its radiative and wind-driven effects. The gravitational interactions within the nebula can also influence the dynamics of neighboring stellar systems. As stars form and move within the nebula, their gravitational pull can perturb the orbits of other stars and planetary disks. These interactions can lead to a range of outcomes, from the gentle nudging of stellar paths to the dramatic ejection of stars from the nebula altogether. Such gravitational interactions are a reminder that the Orion Nebula is not a static environment, but a dynamic and ever-changing stellar cradle. Observational challenges. Nestled in the constellation Orion, approximately 1,344 light-years away, the Orion Nebula is a vast, luminous cloud of gas and dust where new stars are born. This stellar nursery, visible to the naked eye as a fuzzy patch in Orion's sword, presents a treasure trove of cosmic wonders. However, observing these wonders isn't straightforward. The Orion Nebula, despite its relative proximity and brightness, poses significant challenges to astronomers. One of the primary hurdles is its sheer size and complexity. Spanning about 24 light-years across, the nebula is a labyrinth of dense clouds, bright stars, and intricate structures. This complexity makes it difficult to observe in its entirety, even with advanced telescopes. Different regions within the nebula exhibit varying densities, temperatures, and compositions, requiring astronomers to use multiple instruments and techniques to capture a comprehensive picture. For instance, visible light observations reveal the nebula's stunning beauty but can't penetrate its densest regions. In contrast, infrared and radio observations can peer through the dust, exposing hidden stars and protostars. Another challenge lies in the nebula's dynamic nature. The Orion Nebula is a bustling stellar nursery where gravity, radiation, and stellar winds constantly shape and reshape the landscape. This dynamism means that the nebula's appearance and structure can change over time, making long-term observations crucial for understanding its evolution. However, these changes can also make it difficult to track individual stars and protostars as they move and evolve within the nebula. Moreover, the intense ultraviolet radiation from the massive stars in the nebula's heart ionizes the surrounding gas, creating a complex interplay of light and shadow that can obscure other features. Furthermore, the Orion Nebula's brightness, while a boon for amateur astronomers, can be a bane for those studying its fainter features. The nebula's luminous core can overwhelm sensitive instruments, making it challenging to observe the dimmer regions and objects within it. To mitigate this, astronomers often use coronagraphs or other specialized instruments to block out the brightest light. Additionally, the nebula's proximity to the ecliptic means that it can be obscured by the moon or the sun for parts of the year, limiting observation windows. Despite these challenges, the Orion Nebula remains a prime target for astronomers, offering invaluable insights into the processes of star formation and the early evolution of stellar systems. Each observation, each discovery, adds another piece to the cosmic puzzle, deepening our understanding of the universe and our place within it. Future research directions. The Orion Nebula, a vast cloud of gas and dust, has long captivated astronomers with its stunning beauty and role as a stellar nursery. This celestial wonder, visible to the naked eye, is a hotbed of star formation, where new stars are born from collapsing clouds of molecular hydrogen. Future research directions in studying the Orion Nebula are poised to unlock even deeper mysteries of star formation in the early solar system. One of the most exciting avenues is the use of advanced telescopes, such as the James Webb Space Telescope, JWST, which can peer through the dusty veil of the nebula to reveal the intricate details of protostars and planetary disks. These observations promise to provide unprecedented insights into the early stages of star and planet formation, shedding light on the processes that give rise to new solar systems. Another promising direction is the study of the chemical composition and dynamics of the Orion Nebula. By analyzing the spectra of light emitted by the nebula, astronomers can determine the abundances of various elements and molecules, which in turn reveal the conditions under which stars and planets form. This information is crucial for understanding the chemical evolution of the universe and the origins of life. Additionally, the study of stellar winds and outflows from young stars within the nebula can provide clues about the feedback mechanisms that regulate star formation. These processes are thought to play a critical role in shaping the structure and evolution of the nebula, and their detailed study could revolutionize our understanding of stellar nurseries. The Orion Nebula also offers a unique opportunity to study the interaction between massive stars and their surroundings. The presence of massive, hot stars within the nebula can have a profound impact on the surrounding gas and dust, ionizing the material and driving powerful stellar winds. These interactions can trigger new waves of star formation or, conversely, halt the collapse of molecular clouds. By studying these complex processes, astronomers hope to gain a better understanding of the life cycle of stellar nurseries and the factors that control star formation rates. This research is not only important for astrophysics, but also has implications for our understanding of the Milky Way galaxy and the broader universe. Furthermore, the Orion Nebula serves as a natural laboratory for studying the formation and evolution of planetary systems. The nebula contains numerous protoplanetary disks, which are the building blocks of new planetary systems. By observing these disks, astronomers can learn about the processes that lead to the formation of planets, moons, and other celestial bodies. The data collected from these observations can be used to test theoretical models of planet formation and to refine our understanding of the early solar system. This research is particularly exciting because it has the potential to answer fundamental questions about the origins of our own planetary system and the conditions that gave rise to life on Earth. The Orion Nebula in popular culture. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, the Orion Nebula is a celestial spectacle that has captivated human imagination for centuries. This vast interstellar cloud of gas and dust is a stellar nursery, a place where new stars are born. Its vibrant hues of pink, green, and blue, visible through even modest telescopes, have made it a favorite subject for astronomers and a source of inspiration for artists, writers, and filmmakers alike. The Orion Nebula's prominence in popular culture is a testament to its awe-inspiring beauty and the sense of wonder it evokes. In literature, it has been used as a backdrop for tales of adventure and discovery. For instance, in Arthur C. Clarke's 2001, A Space Odyssey, the nebula serves as a mysterious and enigmatic destination, symbolizing the unknown and the vastness of space. Similarly, in the Star Trek universe, the Orion Nebula is depicted as a treacherous region of space, home to the Orion Syndicate, a powerful and ruthless criminal organization. These portrayals highlight the nebula's dual nature as both a place of creation and danger, reflecting its complex and dynamic real-life characteristics. In visual media, the Orion Nebula has been featured in numerous documentaries and films, often serving as a symbol of the cosmos' grandeur. The Hubble Space Telescope's stunning images of the nebula have been widely circulated, inspiring awe and curiosity in viewers around the world. These images reveal the intricate details of the nebula's structure, from the dense pillars of gas and dust where stars are forming to the brilliant clusters of young, hot stars that illuminate the scene. The nebula's vibrant colors and dynamic shapes have also made it a popular subject for artists, who often use it as a source of inspiration for their work. The Orion Nebula's cultural significance extends beyond its depiction in media. It has also played a role in music, with several bands and artists referencing it in their lyrics and album art. For example, the progressive rock band Yes released an album titled Going for the One, which features a song called Awaken. The song's lyrics include a reference to the Orion Nebula, using it as a metaphor for spiritual awakening and enlightenment. Similarly, the band Tool has referenced the nebula in their lyrics, using it as a symbol of the cosmos' vastness and the human search for meaning. These references highlight the nebula's enduring appeal as a symbol of the unknown and the mysterious. Educational value and public engagement. Nestled in the constellation of Orion, approximately 1,344 light-years away from Earth, the Orion Nebula is a vast, luminous cloud of dust, hydrogen, helium, and ionized gases. It's a place where stars are born, a stellar nursery teeming with activity. The nebula's vivid hues, visible through even modest telescopes, offer a breathtaking view of the cosmos. Its brightest stars, known as the Trapezium, are young and hot, their intense ultraviolet radiation causing the surrounding gas to glow in a dazzling display of cosmic artistry. The Orion Nebula's educational value is immense. It serves as a natural laboratory for astronomers to study star formation and planetary system development. By observing the nebula, scientists can gain insights into the early stages of stellar evolution. The nebula's proximity and brightness make it an ideal subject for both professional astronomers and amateur stargazers. Educational institutions often use images and data from the Orion Nebula to teach students about astronomy, physics, and the vastness of the universe. For instance, the Hubble Space Telescope's detailed images of the nebula have revealed intricate details of the star-forming process, including protoplanetary disks, which are the early stages of planetary systems. Public engagement with the Orion Nebula is equally significant. The nebula's visibility and striking appearance have captivated people for centuries. It's a popular target for amateur astronomers and astrophotographers, who share their observations and images with the public. These shared experiences foster a sense of wonder and curiosity about the universe. Moreover, the Orion Nebula is often featured in public outreach events, planetarium shows, and documentaries. These platforms make the nebula accessible to a broader audience, inspiring people to learn more about astronomy and the cosmos. The nebula's beauty and scientific importance make it a powerful tool for engaging the public in the excitement of scientific discovery. Key discoveries and contributions. Nestled in the constellation Orion, approximately 1,344 light-years away from Earth, the Orion Nebula is a vast interstellar cloud where new stars are born. This stellar nursery is a hotbed of activity, with over 700 stars in various stages of formation. The nebula's luminosity is due to the intense ultraviolet radiation from these young, massive stars, which excites the surrounding hydrogen gas, causing it to emit a characteristic reddish glow. This vibrant display is visible to the naked eye under clear, dark skies, making the Orion Nebula one of the most scrutinized and celebrated objects in the night sky. Among the most significant discoveries in the Orion Nebula is the presence of protoplanetary disks, or droplets. These are dense regions of gas and dust surrounding young stellar objects, which are the building blocks for planetary systems. The Hubble Space Telescope has captured stunning images of these droplets, revealing intricate details and providing valuable insights into the early stages of planet formation. The study of these disks has shown that our solar system's architecture is not unique, fostering a deeper understanding of how planets form and evolve. The Orion Nebula has also been a treasure trove for astronomers studying stellar evolution. Within its boundaries, scientists have observed a diverse range of stellar phenomena, from the birth of new stars to the violent deaths of old ones. The nebula's central region, known as the Trapezium Cluster, is home to a group of massive, young stars that are still in the process of forming. These stars are crucial for understanding the dynamics of star formation and the impact of massive stars on their surroundings. Additionally, the nebula has revealed the presence of brown dwarfs, substellar objects that are too small to sustain nuclear fusion but too massive to be considered planets. These discoveries have expanded our knowledge of the stellar census and the processes that govern star formation. Moreover, The Orion Nebula has contributed to our understanding of the interstellar medium and the chemistry of the universe. Spectroscopic studies have identified a rich array of molecules within the nebula, including water, carbon monoxide, and complex organic compounds. These molecules are the raw materials for building planets and life, and their detection in the Orion Nebula provides a glimpse into the chemical complexity that can arise in stellar nurseries. The nebula's dynamic environment, shaped by stellar winds and radiation, also offers a unique laboratory for studying the physical processes that govern the interstellar medium. By unraveling the mysteries of the Orion Nebula, astronomers continue to push the boundaries of our knowledge, painting a more comprehensive picture of the cosmos and our place within it. As we draw our journey through the Orion Nebula to a close, let's take a moment to soak in the marvels we've encountered. We've ventured into a stellar nursery, where the very stuff of stars is forged, and witnessed the breathtaking ballet of cosmic creation. We've seen how gravity's invisible hand gathers gas and dust, igniting the fiery birth of new stars. We've marveled at the vibrant tapestry of colors, each hue a testament to the nebula's chemical symphony. Imagine, for a moment, standing on a hypothetical planet within this nebula. The sky would be ablaze with the light of newborn stars, their brilliance reflected in seas of liquid hydrogen. The horizon would shimmer with the ethereal glow of ionized gas, painting the heavens in hues of red, green, and blue. This is not just a place in the cosmos. It's a cradle of life, a testament to the universe's ceaseless drive to create and nurture. The Orion Nebula is more than just a distant celestial object. It's a mirror reflecting our own origins. Every atom in our bodies was once part of a star, forged in the fiery furnaces of the cosmos. When we gaze upon the Orion Nebula, we're looking at our own family album, a visual reminder of our cosmic heritage. As we leave the Orion Nebula behind, we're left with a sense of awe and wonder. We've scratched the surface of this stellar nursery, but there's so much more to explore. In our next adventure, we'll delve deeper into the mysteries of the cosmos, seeking out other stellar nurseries and unraveling the secrets of star formation. Until then, keep your eyes on the stars. The universe is vast and full of wonders, and there's always more to discover. So, grab a telescope, step outside on a clear night, and let the cosmos ignite your imagination. Who knows what you might find? The universe is waiting, and it's full of surprises. Happy stargazing!